number of real zeros theorem. So it's just that the theorem says that a polynomial function cannot have more real zeros than its degree. So there is no how that a polynomial will have more real zeros than its degree. So it's not possible. So but let's now look at Descartes rule of sign. So this Descartes rule of sign will help us to know the number of positive or negative real zeros of a polynomial. Yes, even without solving, we can guess how many positive or how many negative real zero, not complex zeros. So because we have complex zeros. So let's now say they say let f denotes a polynomial written in standard form. Then the number of positive real zeros of f either equals the number of variation in the sign of the non-zero coefficient of f, else equals that number less than an even integer. So we are saying that it has two conditions. The first one is this, while the second one is the other one down. So we have two conditions. This first one, this is second one. So we are saying that for it to have a positive real zeros, it is always equal to the number of variation of sign of the function fx, or less than it by an even integer. I will explain with an example. Why the number of negative real zeros of f either equals the number of variation of sign of the non-zero coefficient, or less than it by an even integer. So this is just grammar. So let's now use the equation to explain that. So example, if you are asked discuss the real zeros of this, so we're asked to discuss, like to tell how many positive or negative real zeros of that. So we'll use Descartes rule of sign. So it's simple to use. Variation means change of sign. So you check where sign changes. Let me get a red pen, or maybe this green. So there is change of sign here, plus to minus. So it says that the number of positive zeros will be equal to the number of change of sign. So we have only one change of sign here. So meaning that positive 0. So we have 8. So it will have 1 positive 0, because we have only one sign, change of sign. So let's now check the number of negative 0. So it means that if you substitute minus x, because from the theorem, check, they said variation of sign in the coefficient of f of m minus x. So let's substitute minus. So we have 3 minus x raised to the power 6 plus 4 times minus x raised to the power 5 plus 3 times minus x raised to the power 3 minus 4 times minus x minus 5. So let's see what we have. This is the same 3x raised to the power 6. Why this is minus 4x raised to the power 5. This is minus 3x raised to the power 3. This is plus 4x and minus 5. So how many change of sign? Variation of sign. So let's count. So we have 1. This is 1. How many again? We have 2. And we still have 3. So meaning that we have what? 3 negative real zeros. Negative must be real zeros. Negative real zeros. Remember, there is one thing they said here, or less than it by an even integer. So the first integer, even number, is 2. So we subtract 2. So we're saying that it's either it has 3 negative real 0 or 1 negative real 0. That is less than it by an even integer. That is 3 minus 2. 1. So it's either we have 3 negative real 0 or 1 negative real 0. So in conclusion, So you see that f of x, we have the total of, so if I have one positive real zero here, remember the highest power here is 6, so you must have 6 roots or zeros. Since I have what? One positive and I have 3 here, so what do you have to say? So it's either I have 4 real zeros, or how many? 2 real zeros. Yes, 2, in the sense that if you have one positive and have one negative, so the total is 2. So if you have 4 real zeros, meaning that the other 2 will be complex 0, or if you have 2 real zeros, the other 4 will be complex roots. So the total, so it's either 4 real zeros, or so we have either 4 real zeros or we have 2 real zeros. So that's what we are saying. So coming to the second one, we apply that same logic. Using that same logic, we see that for f of x there is variation. Let's check how many variation of sign. So I have, this is 1, this is 2, this is 3. So we have either 3 positive roots, positive real roots, real zeros or roots, or 1 positive real. I told you it's always, or is less than it by an even integer, so which is 2. 3 minus 2 is 1. So let's check for negatives by substituting x as minus x. So I have f of minus x is now 2 times minus x raised to the power 6 minus 2 times x minus x raised to the power 5 minus 3 times minus x raised to the power 4 plus 6 times minus x raised to the power 3 minus x raised to the power 2 minus 4 minus x, and finally minus 7. So let's see. This is still 2x raised to the power 6. This is negative, so plus x raised to the power 5. This is positive, minus 3x raised to the power 4. This is negative, so minus 6x raised to the power 3. This is positive, minus x raised to the power 2 plus 4x minus 7. So how many variation of, let's know the number of variation of sign. So we have 1, we have 2, and we have 3. So we have either 3 negative real zeros, or less than it by an even number. That's 3 minus even integer. 3 minus 1, 2 is what? 1. So either this or that. So in general, or in conclusion, fx, we have either, if we have 3 positive, 3 negative, so it's either it has 6 real zeros, or if it has 3, it's possible to have 1, that is 4 real zeros. So any other one, okay, 1 and 1, 2, so, or 2 real zeros. So that's it. So these are the possible real zeros. Is either 6 real zeros. 6 real zero means no complex roots or zeros, or 4. If it has 4, it's now 2 complex roots or zeros. 2 meaning 4. So these are the possible real zeros. that fx will have. So thank you.